We are starting with a mounting flange sent to us as a Parasolid XT file by one of our customers. In this example, we're going to look at one of the ribs to determine how it reacts to a force being applied to it. There are a set of features in the back which are not really needed for this analysis. Note that they have a lot of detail, which can slow down the meshing and solving process. To speed things up, therefore, we're going to use Synchronous technology to remove these features. We now want to create a new study to look at one of the ribs. We can create as many different studies in this part as we want. In this case, it'll be a linear static study using a tetrahedral mesh, the default. No material is defined for this part yet, so we can assign it here from the simulation ribbon. Next, we want to create a force on one face of the rib. To better see the symbols for this demo, we will increase the size and density of the symbols and also display the value of the force in the UI. We are not going to constrain each side of the mounting flange. We are now ready to mesh and solve. For the first run, we will view the mesh first to see that it is what we want. We can create a coarser or finer mesh using the slider. This mesh looks acceptable for this first run, so the next step is to solve the model. Solving can take a while, depending on the size of the model. After solving, we can view the results. We can see that the maximum stress is 0.91 megapascals at the base of one of the ribs. Note that the other ribs don't have much effect on the results. Let's see if we can reduce the stress by making some changes to the geometry using Synchronous technology. First, we'll thicken the rib by dragging the face out. Next, we'll increase the radius of the fillet around the base to reduce stress concentration. Since the extra ribs are not really of interest to us, and because they slow down the analysis, let's remove them from this model. This will give us faster mesh and solve times. Lastly, let's thicken the base of the rib, since it was warping a bit in the last analysis. We will add some PMI so that we can see the extent of the change. The solve time was cut in half after removing unneeded detail. We also managed to bring down the maximum stress from 0.091 megapascals to 0.024 megapascals.